Afternoon, everybody. How we doing? God, I didn't realise what the time was then. I was just going to go up in the loft and grab my version of this radio down, but I just glanced at the clock and it was 2 o'clock. But yet my clock here says 13:57. So apparently I'm 3 minutes early according to the computer, but I'm not. I'm not. So we got a few people in by the looks of it. We got Timothy in. Hi, Timothy. And Dwarf. And Simon's World. And Fat Tony. How you doing, Tony? Not seen you for a while, mate. Hope you're okay. Mac Vision. Hi, Mac. Hi, Mac. Hi, Mac. Derek Cooper. And thanks for the super chat, Tony. Aaron, how are you, mate? Yeah, it's been nice. It is getting a little bit overcast now, but it's quite cold out there. I think it was about 12 degrees outside. So it's starting to get a bit cooler, which is nice in a way. Hello, Chris. Chris Milky, how are you, mate? And Joe Matamble, how are you? Wisconsin, USA. Michael Hyde, hi, Michael. Paddy, hello, you see, how you doing? Dids. Oh, you're gonna hate me, Dids. I haven't got one. I have no finger to put in me today. Got some other things I can put in though, but no finger. Timothy's having another speckled hen. Nice drink, speckled hen. Have you tried the? There's a crafty hen, isn't there? There's a few. There's a crafty hen, and there's another one that's a bit stronger. They're all nice. Danish, how you doing, mate? Mike Cass, hi Mike. Nick Petronics, hi Nick. Afternoon, Rob. A huge thank you to me. Why is that, Chris? It's not arrived already, surely. Christian, hi Christian, from Germany. Just been watching the darts in Germany, Christian. Bavaria, very nice. Ben Humphreys, how you doing, Ben and Sandra? Sunny Scotland. It's got to be cold up there, Sandra. It must be cold. It's always cold in Scotland. Bob Anderson, how you doing, mate? This is the usual time, Bob. It's only when I mess about with the times that everything goes wrong. It's supposed to be down into single figures tonight, Aaron, I think. Afternoon, Benji, in and out. What are you up to, Benji? Peter Carr, all right, Peter? So we've got a radio in from Mark today. Done a few repairs for Mark in the past. I'm not sure where Mark's from, actually. I'm not sure if he's put a return address in his letter, has he? No. No, but this is in from Mark, who I've done some repairs for before. So obviously he must have been happy with them, because he sent me another one. And I've got one of these radios myself, and I've repaired one before, which was a bit of a headache, but I did get there eventually. David Tipton, how you doing, David? Mick McGinn and Rob. Oh, you're welcome. -3 last night, Sandra. Flipping heck. Soft, a slow, comfortable screw. Yes, yeah. There's lots of them. There's lots of weird named cocktails, Aaron. 2.7 last night. Joe Fanach, how you doing, mate? From California. Got to be sunny over in California, Joe, surely. Andrew Pitt, hi Andrew. You have a nice 104. It's a lovely sounding radio, I'll tell you. Lovely sounding German radio. Hi AD. So yeah, I have repaired these before. Has Manuel done one of these? I think Manuel has done one of these, hasn't he? Mr. Caldera. Electronics old and new. Yeah, sunny. Always sunny in California. Multi, good afternoon to you, Multi. All the usual suspects in. Not heard from the old man cave for a little while, actually. Not heard from Sean for a few weeks now. Well, about 3 weeks. So hopefully he's doing okay. So we need to get something in me because it's a little bit dry here. I think what I'll pop in first is again, it's a local beer. Let's go with a local one. Let's go with the local one. Mrs. Cruncher picked this up for me last night, so it was a bit lastminute.com, but we've got beer in the house. We have beer in the house. And it is legend. It's not the beast, it's legend. Electronics older than me. What? Good one, Joe. Afternoon, Murat. How are you? From Istanbul. Thank you very much, mate. Rob's learning the banjo. In your opinion, you can't beat the sound of Volve equipment. Yeah. There's lots of different ideas about sound quality and all this modern stuff that we're seeing these days, all these electronic files that are supposed to sound better, and CDs are better than tape, and tape is better than CD, and it's never ending, isn't it, really? So it's each to their own. I mean, these radios here do sound very, very nice, and they're very sensitive as well. Very good performance all round. So you'd be hard pushed. This is up in the Grundig territory. This is. I mean, these are really good quality radios. I'm pretty sure Manuel did one of these, but I can't remember off the top of my head. But anyway, the Dartmoor Legend from Princetown Brewery in Devon is on its way in. Yeah, it's shaub-lorenz, if that's how you pronounce it. Is it shaub-lorenz? Or shaub? I really don't know how you pronounce it. But they've done some different versions of this. Now there's a 104 and there's a 104A. There's this one and there's a studio version which has got a silver front on it. This one here is actually in really good nick. It's really good condition. I can't see there's any cosmetic issues with it whatsoever. I mean, even the dial there's not a scratch on it. It really is in good condition, this. Really is good. It is almost mint, I would say. A bit of something there, that's just a little bit of dust got in the grill, but I would say it's almost mint, this radio. It's very, very nice. Thank you, Rob. Cheers, mate. No finger over there, Joe. Oh dear, oh dear. Simap, how are you? Not to be found. Pry, Ben? Pry? Polygamy Porter. Luigi, how are you, mate? Oh, Polygamy Porter. Porter's nice. I like Porter. Cheers, Joe. Yes, it is. Princetown of Dartmoor Prison fame. You are right. Afternoon, Andrew, little boy. Just getting over COVID. Oh no, there's a lot of it about again, isn't there? I was supposed to have my COVID booster on Friday, but still got a bit of a sore throat about me, so I thought I really don't want to firstly risk giving that sore throat to anybody else, plus risk it getting a lot worse by having a COVID jab. So I've sort of dipped out of it for a minute, but I must get the booster done. Well, I think you can get it on Amazon. I'm sure you can. You work in copper manufacturing. Give me a copper mug. Very nice, Murat. So can you drink out of a copper mug? I mean, you must be able to. This is pewter, and it's got like a brass rim on it and a brass base. But pewter is what is pewter? It's not. Is it like it's an alloy of some description? Is it a silver alloy? I'm not sure now, but it does tarnish inside. There's some lovely things made in copper anyway. Yeah, still not 100%, Rob. Still got a bit of a dicky throat and really tired, I think. Whether I had a bit of a dose of COVID and I didn't notice it, I don't know. But certainly haven't been feeling great recent weeks. But, you know, I'm getting there. I'm getting better. I'm getting better by the week. So every week's better, Rob. That's the main thing, isn't it? So, the story with this one then. Electrosound, how you doing, mate? The story with this one, I've got this in from Mark now. And he's saying, where are we? Now, this is from 1973, apparently. I've not confirmed that, but Mark has saying it was the flagship model in 1973. He's also saying it's the best sounding FM portable he's ever listened to. And it looks like new. But unfortunately, when he lifted the radio out of its sleeve, he damaged the wiring from the mains transformer. So pretty much what he wants me to do is to chop out all of the mains wiring and just leave it as a battery-only set. Which sounds simple, doesn't it? But these radios are never simple. I mean, I just had a quick look at the schematic just now, and there's God knows how many connections on the on-off switch. There's switches throughout the radio. There's wiring all over the shop in the thing, so I can see why he sent it out to me. So he said he's removed the mains transformer and its wiring, and he wants to operate it from its 8 D-cell batteries, and he's not figured out which wires to connect. And one of the lamps has failed as well, which is no surprise. I've got one of these myself, and both the lamps have gone on mine. The one I had previously, I did an LED conversion on, which is really simple in these. Really simple. You just got one. You got one resistor and 2 series LEDs, and they work fine. He's discovered that the pin on the on-off switch was missing, the lower pin. So yeah, this is it. So we have got somewhere here, we've got the transformer that's been taken out of it. Now these radios, you unscrew the screws from the bottom, the cover slides up off of the radio, it leaves the chassis in place. We've got some various bits and pieces in here. There's some little bits of wire and the aerial in that bag, and some screws by the looks of it. Sorry about the paper rustling. We've got the little thingy there, which is for the altering the presets, I believe. And this is transformer inside here, so let's have a look in here. It's good stuff. you must be able to get some legend over there. Dartmoor Brewery in Princetown, and yes, it is the same place as the infamous Dartmoor prison. Let's get that one out of there. So this is the mains transformer. It did say it was damaged beyond repair, the mains transformer, so I'm not sure what the situation is. So we got some bits and pieces of screws here. So I'm not sure. I mean, it's a shame because I'd like to probably try to get it back working again. It doesn't look like the actual windings are damaged. Let's just get you down on the bench and have a look at this transformer in a bit more detail. So it looks like there's a switch in the socket here that switches across, probably between mains and battery. I don't know. Again, there's so many switches all over this thing. This might be a bit of a head scratcher, this one. So yeah, we've got a switch in there that must be connected to the battery. Must switch the batteries out there, I would have thought. That switch is missing. There should be like a little black plastic bit in there that operates the switch. That's gone. And looks like we've got some wires just cut off there. So we've got a blue and a green cut there. We've got a stripy and a red cut there. We've got this one here, which just looks like a ground wire, which probably went on to one of these. Probably that one, maybe to here. I'm not sure. It might be that I'm going to have to go and get mine to suss it out, but so basically what he wants to do is throw that lot away, so that's gone, and just have it working on batteries. As I said, that's probably easier said than done. So if we switch over to the schematic and have a look. Tony, thanks for the super chat, mate, as well. Hope you're doing okay, mate. It is a bit of a jigsaw puzzle. It is a little bit fortunate that I have got one of these myself, so that is going to help me no end. Okay. So if we go over to my screen here, let's make this a bit bigger. Just get rid of me a minute. So if we have a look down here, this is the main side of it, and all the some of the switching. The switch is everywhere on this thing, literally everywhere. So we've got a fuse that's switched in there. Look, between those two. We've got this here. Now, whether that's the switch in the mains socket, it potentially is, to switch between battery and mains. So it looks like it's probably switched to the battery side at the moment. It can't, because that switch there is not made. So if we go across here slightly, you can see the switch bank. Now this one here, I take it is the on-off switch. Now we've actually got two sets of terminals on here. We've got 1 to 6 and 1 to 4. It says switch 1 and switch 2 are on this one. So are we assuming this is switch 1 on the top and this is switch 2 on the bottom? I'm not sure. So if switch 2 is on the bottom, then that looks like the leaf switch in the main side, doesn't it? There is another switch, which is that one in the transformer, in the socket. So we've got switch 3 over here, which is a light switch. So we don't need to worry about that for now. We've got switch 2 there. We've got switch 1 down here. But if we go up, we've got more switching up here. Look, we've got switch 2 up here and here. So and that looks to be in the output circuit. So let's switch in this socket here to ground by the looks of it. And we've got another switch 2 there. So yeah, there's another part of it there anyway, switch 2. This one doesn't seem to be marked. 4, 5 and 6. I mean, is that the same switch? Well, that's tape. It says TA there, so that must be tape, which is this one. So is there another switch in it? There's probably a switch somewhere else. TA and TB? Is that another switch? Is that the TA switch then, probably? Yeah, that could be the TA switch, couldn't it? Yeah, that's the TA switch there. But certainly there's a switch in here. It could be anywhere, couldn't it? So it's 6, 5 and 4. So if that's 6, 5 and 4, that would be this top switch here. So are we saying that this is switch 2 then? Because it's got 6, 5 and a 4 on this switch. Well, I don't know, it's complicated, isn't it? So it looks like switch contacts shown in U position. Okay, it's complicated, basically. So, just seeing if there's any more switching on here anywhere. That thing's switching power everywhere, I expect. So we've got another part of the schematic here. I'll zoom that one up again. Got any more switches over on this section? No, this is the band selector switching. It's a medium wave switch, K4 switch, which is the one of the shortwave bands. So now it looks like that's band switching on that part of the schematic. Let's come over this way, make sure we've got nothing else. K4, K1, K4, that's all medium wave, shortwave bands, AFC, K1, K4, long wave, more switching, U1, U2, U1, U2, oh, there's switching everywhere in this thing, isn't there? So yeah, it looks like all the switching for that particular on-off switch is done down here. So we might need to do a little bit of bridging here. We don't need this switch anymore. But we clearly need that one made across. But we still want the on-off button to work. Switch 3 we don't need to worry about. Switch 1 we don't need to worry about either, so switch 1 is irrelevant now. It's just switch 2, which seems to have 1, 2 and 3 there, and up the top here it's got 4, 5 and 6. There's got to be that top switch there. There's got to be this section here that we need to worry about. So it's time really to jump inside and have a look, I think. See what goes on, see what's occurring. It's complex though, isn't it? For squeezing jiffy bags is relaxing. So electrical sensing 1 and 6 is switch 1, 1 and 4 is switch 2. The key is about above the switch diagram. Okay. No, it didn't ask for a DC power connector on the outside. I don't know if there might even be a DC power connector on this thing. There's loads of stuff on these. So these knobs were off when I got it. So I'm going to pop those off again because I think it needs... God. God, dear, oh dear. Maybe I shouldn't have put these back on again. Very well made radio. There's even little bits of felt in behind the switch to stop it rubbing on the glass. Very, very well put together radio, this. Right, let's get a little pot to start putting bits in. I put those back on just for photography purposes, really. Now, let me have a think. This comes off there. Now there's something floating about inside. Don't know what that is. I'm trying to think how you get these apart again now. I know it sort of slides up from the top. Just trying to see where the screws are that has already been taken out. So it looks like it's all ready to go up, pull up through. Maybe that one's got to come out, I think. I think maybe that one's just got to come out. A long old screw, isn't it? Didn't somebody mention about that earlier? Right, now that should come out of there, or do I need to undo those as well? Okay, that's our loose screw there, look. There's a screw and a nut loose there. A screw and a washer even. That's what was rattling about inside. Not sure where that's come from. A big old speaker, look. And a tweeter. Oh, that's why they sound good. This is going to be painful, I know. Look, I see down inside here we've got some contacts as well, look. So this is the battery tray. That's a positive and negative there, so that must clip into somewhere on the board. And this is where our D cells go. This is definitely a 104, not a 104A. I can't remember what the difference between the 104 and 104A is, but they did change some components in them. I can't remember whether mine's a 104 or 104A. So yeah, that must make contact with something on the back of the radio. Over here. So yeah, that just makes contact with the board there. We've got other wires disconnected here, which I'm not sure where they go. That's going to be fun, this, isn't it? Okay. Have we got anything else floating about inside? No, I don't know where those two screws there that screw and washer came from. Must have been holding something on somewhere. Maybe it's the aerial screw, perhaps? Don't know. I suspect I'm going to have to go and find my radio. We'll see. So, where did this thing sit to? Was it in behind the speaker? Was it lumped in there? Let's have a look. Color tint control, Tony. What do we mean? So clearly that went in there. Don't know. Looks like there's some screw holes there. I wouldn't have sat down there, would it? I could have done. Okay, so what do we know so far? We know we haven't got that. What's that? We got wires here, which I'm not sure what they do. That's our positive and negative battery terminals there. So they're just on the print on the circuit board. I'm going to pop the speaker out and have a look underneath the speaker. I think it's 8. Yeah, I think it's 8. It's 12 volt. Yes, it's got to be 8, isn't it? 8 D cells, I believe, Aaron. Very well manufactured, isn't it? Little sockets for the screws, look. I'll put these screws back in where they came from so I know where they go. So I'm going to have to take a lot of screws out of this thing, I think. Now, I had problems with the last one I had of these. I had some burnt tracks on it and it wouldn't work at all. I think that's going to be the case here. I just need to get up in and have a look at the switching up the top here, because the on-off switch is up this side, in underneath here somewhere, which is why I'm taking the speaker out. And that speaker's connected to that one with a crossover, so I might as well pop them out as a pair. So let's whip this one out as well. Taped in. Glued in, I think. There we go, that's that. Oh. Well, we've got another screw attached to the magnet, look. So there's no wires attached to it, so that's why. Okay, so there's our speaker. We've got another screw. Always makes it more difficult, doesn't it, when someone else has been in there before. So looking at this, that goes across to there. We've got a fuse there. So that's a 12 volt socket there, that. So that's 12 volt socket, so negative. So we should be able to power it for testing on that socket. I'm just going to pop this plate here off a minute just for a look underneath. Oh, did I hear something? Something else is floating about in here. Ah, another washer. So we have 2 screws and 2 washers which we can't place at the moment. That's our speaker wires. So our tape socket. All fun and games, isn't it? So far, I need another beer after this. So Bob is saying, if S1 contacts 1 and 2 are unused and the only marker C that's needed is to connect S2 contact to 313 and blank off the main socket. Anybody that wants to follow along and download the manual, it is on the Radio Museum. So you need to just type in this on the Radio Museum. If I put that in, I don't think it'll bring in the manual. You probably have to go and download it yourself. But there are manuals on Electrotanya, but they've only got the 104A on Electrotanya, not the 104. And as I say, they are different. You've been wrong before. Don't worry. Don't worry, Bob. Any help is always appreciated, mate. I do try and listen to it. So yeah, 1 and 2. Oh, I can see the switch now. Switch. I think that's the switch there, yeah. So all the contacts for the switch are up the top here. So this is the switch that we're interested in. And the bottom switch we may be able to ignore, though Bob is saying about connecting. So 1, 2, 3 and 4. Three and 4 we don't need to worry about, but 1 and 2 we need to put across into position. But to be fair, I think it'll still switch because it's connected to the board. I think this will be fine. I don't know that we'll have to link anything out really, but we shall see. That's where that other one goes, in that hole there potentially, is it? 1, 2, maybe that one. Okay. Yeah, I'm just thinking, because I can see all the switch contacts on the board, I need to download maybe the board layout. I'll zoom you in on that part of the board. Where am I? I'm down here and up here. Yeah, that's it. So we'll go that way a little bit. So yeah, this appears to be S2. Was that S1? And this is S1, I think. No, this is S2, sorry. And this here seems to be S1, which is those. I think, was it those? It's just these two contacts here. I think it's just making a contact across that when you push the switch. But we might have to link out that bit that was on here. Yeah, so clearly there was some wiring on this piece, which is the switch in the main socket. So that switches the battery contacts out when the mains is on. So we need to find those battery switches and link them back across. This can just be dewired and then screwed back in as a blank socket, never to be used again. So I'm not really worried too much about that. We can get rid of this now because that's just the fuse there. So yeah, we just need to find where this wire into this one went, where it is, and link it across. But this, I don't think this switch is very clear on the diagram. I mean, I think I know which switch it is on the diagram, but I'm not 100% sure. I think a stronger beer is required, Tony, and I do have a champion waiting in the wings just in case. I do have a champion waiting just in case, look. If necessary, the champion's going to go in, and that is that's an eye-watering 7.3%. So if necessary, I have got a secret weapon. So we'll see how we get on. Again, bought by Mrs. Cruncher for me very kindly last night. Okay. I'm wondering whether these two wires here, where are they gone to? Yeah, whether these two wires here was something to do with that switch. These down here that are hanging in the, blowing in the wind. Are you going to focus? So we've got a wire here and a wire here just floating in the breeze. I don't know whether that's our switch or not for the main side. So we've got a headphone socket, I believe, haven't we? Yeah, we've got an external speaker socket, so we can potentially bypass the speaker and just stick a normal speaker in there. And we can bypass the battery and stick a 12-volt supply in there, and then try and work it out from there. It might be worth me just going through the schematic a minute and see if I can find what the hell's going on. I don't bother with one myself, Rob, but if you go and look at Manuel's channel, he has built himself a little speaker setup. Because the problem is there's so many different impedance speakers that we use. It would be very difficult to get them all. You could have some sort of resistor box to switch all the different types in, but it's just too much hassle, really. Now, what's the speaker on this one? Have we got an ohms for the speaker? So it's 4 ohms in series. Does that make it 8 ohms? 2 4s in series? Well, they have got a capacitor in between them. Not sure. McEwen's, I know, Tony. You did say we need a stronger one. I'd be the same, Aaron, to be fair. I would try and rewire all this in because it doesn't look to me like there's a break in it. All the wires are there. You did say the transformer's windings are broken, but I can't see it. Yeah, it is a shame, isn't it? But you know, it's Mark's radio. If he wants the transformer out of the question, then out it will go. I just need to find out where these wires go. So it looks like one side goes to the battery positive. One side goes to the transformer and the other one is the power out. Let's pop this screw out here. See, there's a burnt connection there and the wire had been botched across. So it looks like someone's been in this one before. There's a wire there just hanging off that. It goes to there. Right. That's this one here. Yeah, see, that's all melted there, so that's not usable anymore. Let's see if the service manual's got any more info on it. Oh, just a 4 ohm, is it, Bob? Thank you for that. Yeah, the bishop's really not going to be happy with me. I think the transformer is okay, Aaron, but there's lots of issues. The battery switch is all melted in it, so that's not going to work anymore, I don't think. And the plastic bit that switches the batteries in and out is missing. I think the transformer's fine, but it is a 12-volt transformer. I don't know what it's rated at, but should be fairly good. Build a nice little power supply with that. Looks like it's got 16.2 volts offload. So I think that's our two contacts there, 313 and 310. I think we just need to join them together. Point 313 and 310. Okay. So if we go back to the schematics, let's get rid of me for a minute. You don't want to see me. So I'm looking down here on this part of the circuit. So this is clearly our switch in the socket here. So it's shown at the moment in the battery position. So you plug the socket in, and that makes that contact go over to there to enable the mains going through the bridge rectifier, blah blah blah. So the two that we need to join are points 313 and 310. We need to join those up. So I think that's probably those two wires, but if we can find out where it is on the board, I can just link those 2 points on the board, and that'll get rid of this switch altogether. We don't need to worry about switch 1. If we get rid of that, then I think this switching will still stay the same, because switch 2, when we push it on, it'll push it across to there to switch it on from a battery point of view. Yeah. So I think it's not too difficult, as Bob said. So just got to find points 313 and 310. So if we go back to the schematics, we need the layouts really then. It's one of these. Is it that one? Print PDF? Let's have a look. Oh. It's kicked me out again. Aha, right, yes it is, potentially. Let's zoom in on this. So this is the area of the socket down here. BU303, but where is that? So we said we need to link 313 and 310 together. 313 and 310. Okay, looks like that. Is that 310 there? Is that 313 there? Yeah, here we go, here we go. I'm on it now. So that coming down to there. Down, so that's 313, which is that little funny birdie looking thing there, and then that's where that red wire is coming off of. And 310 over here is the other part of the switch. So 310 is the first, second, third one up. First, second, third. Which doesn't appear to have anything on it at the moment. So what's this one up here that's off then? See, we've got a wire in there by that resistor. Oh God knows, is that one supposed to go across there, I wonder? Well, definitely we've got to join 310 to 313. We've got to join those 2 points there according to that. It's difficult to see, but I'm sure that's 310. So 38, 39, 310, 311, 312. And that's 313. So we've got to join that one to that one, which makes that switch. So here's our 12-volt input socket. I can't for the life of me see that there was ever a wire attached to that terminal. That's the only thing that I'm worried about. Yeah, there is a stub of a wire in there. Okay. So maybe that did have one. And that's definitely that red one. I'm really not sure what this one is. Oh, hang on, that's just jammed. That would explain it. Where does that go to then? It goes up to here. I'm just trying to find, there's another stray wire which I thought was connected to that, but it's not. It's just jammed underneath the case. It goes up to here, and it's a red and green striped wire. It goes to that point there, which is on the bridge rectifier. Where does that go to then? I think that one went to the transformer, you know. Yeah, I think that's a transformer wire, so I don't think I need to worry about that. Okay, I think I'm there. I think I've sussed it. Right. Let's do some messing. So as far as I can see, let's get you down on this side of the board. As far as I can see on the schematic, this point here needs to be connected across to this point here. Now there is a wire in there, but there's nothing on the other end of it, so that's clearly snapped off. So it was probably, well, it could have been this stray wire here perhaps, I don't know. No, it can't be, could it? There's definitely a wire snapped off, but in this little packaging here there was a couple bits of wire snapped off, look, so I suspect it was one of these two. It would have been one of these two wires that used to live in that hole. Looking at it there, it looks like it's that one there. So I suspect that's it there. So that would have been in there, that one there, and those two would have been our wires going on to our switch. So I mean, for the time being, I can just connect that one to there as a temporary test. So I'm going to do that. That screw back in there a minute, just so I know where that came from. Just solder that a bit better because it's not very well soldered. And that one, just put a bit of a flux on that. So you can take that wire out now because that's not needed anymore. Just stick that one on. So that's now our link between those 2 points. What else have we got to do? We need to connect a speaker in. I've got an 8 ohm speaker, which is better to have a higher ohm than a lower ohm. See if I can find my speaker wire. Speaker connector, I mean. Will that fit in there and make contact? Yes, okay, so that's our speaker in. So that's our speaker in. We need a 12 volt in that hole there. And does it say which is which? No, it doesn't. It doesn't say which is positive and which is negative, which is great. And it doesn't say on there. So look at that one there. That one's positive. Left is positive and the right is negative. Left positive, right negative. So if I buzz that out, I should be able to find out which one's which. So negative is there. Would be if I could hold it in place at the same time. Apologies for the camera. I'll get you back in shortly. So that's the negative there. Center pin negative, I believe. Just see if it tells me on the circuit as well. I mean, I'm going to put it on current limits, so we'll soon know if it's the wrong way round. But yeah, that's definitely positive there. So it's center pin negative. Okay. You'd think it would tell you on the thing on the back, and it's no wonder a lot of these radios get ruined by people connecting them up backwards when it doesn't actually physically tell you. So center pin negative, so if I swap these two round, and there, put the power on, 12 volts. Let's get my power lead. Just quickly check with my meter that we're the right way round. Which we are. So we should be able to pop that one in now. Yeah, that's right, okay. Now, this is where we find out whether our thingamajigger is working or not. Now, where's the volume on this thing? Volume. Bass. Treble, I think. I think this is volume here. So on. Let's go to let's try 30 milliamps. No sound from the speaker, though I did. No, nothing at the moment. So we've probably got another switch that's not made somewhere, potentially. Okay, so what have we not done? So we connected that one and that one together. Okay. Maybe I forgot something. Don, how you doing, mate? Catch you later, Sandra. A ring tester. Yeah. David loves his ring tester. Is David still with us? Has David nipped off now? Apologies if I've missed the chat there. Should be. Am I in the corner? I don't know what screen I'm even on here at the moment. Okay, yeah, I'm on the radio. Okay. Yeah. Hi, Tom and Susie, how are you? So it makes me wonder what this this wire here is for. I really don't know what this wire is for. There's lots of wires that are astray on this. That's our speaker, so we've definitely got a speaker in. And I could forget the speaker for a minute. Let's just pop the power out again. And I could potentially just pop that one back in for a minute. Just for a test in case it's the speaker not working. Doesn't really matter which way round these go. Let's do it that way and that way. Just rest it back on there for a minute. Try it again. Would have if I plugged it in though, wouldn't it? Wouldn't it, Graham? So what's a little pop when I turned it on? Medium wave. No, FM, is that U on this thing? So somewhere we've got something missing in the audio section, I think. I'm not sure what. Apart from the fact we've got this weird wire here knocking about. So further thought needed. So where a switch is missing, I think. See if we can find out where this wire goes, and I think that goes to the transformer, but I'm not 100% sure. Can you see the wire in question? Is that red wire just in there that's sticking up? Red and green one? The mystery wire. So let's get the schematic up again. Let's see where that wire is supposed to go. Need another sip of the beer first, so. So here we are on the back of the board again. So just need to find out which terminal that wire's in. It looks like it's in with that switch. Oh no, it's not. It's on the bridge rectifier. It's right beside the bridge rectifier. Okay, so it's 0.314 by the looks of it, which goes up. Oh, that's the other side of that, so we don't need that. So that was the other side of the battery switch then. So that was what switched the main side on. So yeah, we don't need to worry about that one then. So these two here were definitely connected, weren't they? Make sure I've got these points right. Definitely 313 that wire. And definitely 310 there. 8, 9, and 10. Yeah, unless I'm cracking up, that should work. So why isn't it? So that wire's dead now, because that just feeds the bridge rectifier. Unless we've got to somehow bridge this thing across, but there is no terminals on that side of the board for the switch. All the other switching is in place. Okay, bit of a mystery now. That is a bit of a mystery. Unless, of course, it's been connected up and something's gone pop prior to me having a look at it. But there also appears to be something that was connected to this point. So this one here, there's a wire broken off of that. Where does that one go to? 311. It goes up here. Oh, that goes to the center tapping of the, well, it goes to one side of the output. So that doesn't matter. So that's fine that that one's missing. The next one as well, that must have gone to the other side of the winding, so that's the power in from the transformer on those two wires, which we don't need to worry about because that's obsolete. What's this here then, the green and the black? Where do these two go to? That goes to there and there. So 308, 309, that's another wind-in. What's that for then? That's for the light. Okay, so it looks like the light is on permanently on mains then, but switched on batteries perhaps. Yeah, so that's just another winding for the lights there. That's the lights and that's the outputs. We don't need to worry about any of those terminals. They don't need linking. But it does appear that something somewhere is missing from the amplifier side of it. Let's have a look back at this schematic then. So those 2 points are bridged now. Switch 2 we've still got in the radio. So when switched across, that puts the power across to there, which powers this up. That should then power all this. And at the top here, switch 2. Somehow grounds this out. I'm not 100% sure how that works in relation to that switch, unless it's wrong. And this is very early double-sided circuit board on this as well, so don't need those in, do I, to make a circuit? No. Okay, a bit of a mystery now. I'm really not sure what's going on now. Because that should, in theory, work, as far as I can see, unless someone can see something that I've done wrong. But I'm unsure how this is switched on pins 4, 5 and 6 of that switch. That automatically switch power on to this, and then the second one takes it further. I don't know, maybe that's what it's doing. Just checking around here, make sure there's no other switches that I've forgotten about. Switch 3 is the light switch, we don't need to worry about that, because that would power the light switch in battery mode. Because at the end of the day, the light switch in battery mode is a momentary push just to light up the display to your tune, and then let the button off again so you don't drain the batteries. Have I missed a link somewhere? So this wire is hanging free, but that's not a problem because we don't need that side at all. We've got that linked across there. So that's gone. That's switching across there to put power into the amp, which is here. So let's maybe check that we've got our 6 volts up here on C373. Let's try that, I think. 6 volts on 373, 378 junction. Let's just go. We've got markings on here as well that we can test. All right, yeah, they've made it quite not simple, but they've made it a lot easier for us by giving us the readings down. It's IC301, was that? IC302 is the output. Where's IC302 then? IC302, so this is our output up here. So we've got 6 volts there. I think it says 6 volts. I can't really see it very well. I think that says 6 volts on pin 12. So we need to check that we've got that, I think. So we've got power to our output amplifier chip. Unless anybody says anything different. Anything else that I've missed, maybe. Bob. Check a couple of voltages, emitter of T308. 12 volt across C368. I think we're up here, 373, 379, 376, 3713. It's difficult because I can't read this. Can't quite read it. It's just that little bit ineligible. So we should have 6 volts at pin 12 of this IC here. We should have 12 volts down here. Someone's just said a T308. Okay, so let's check some of these voltages. Let us check thine voltages a minute. I really could do with a printout of that, so let me just print that one a minute. I'll print it out on the laser printer. If it'll let me. Pop it in colour. Just quickly print that one, if it'll let me. Fat Tony. Cheers, Tony. David, how you doing, mate? You had a portable ITT cassette player. First time you got permission to use it, plugged it in and got a jolt up your arm. Excellent. Thank you, Anonymous. I don't know if that's Mr. Danish, but £6.90. Thank you very much for the tip. Andrew's going. Are you off Electrosound? Are you, Andrew? So yeah, voltage time next, isn't it? Voltages. Plenty of places to check for voltages. It's just finding where they are on the board is the key. Luckily, they have given us some information on the schematic, which is going to help a lot. So let's get that so you can see it. Let's grab that off the printer a minute, if I can get to the printer, because I've got stuff everywhere again as usual. Got some good news on the ICOM that we looked at last week as well. One of my viewers from Ireland is very kindly sending me a spare set, which is absolutely amazing. So I've got a spare ICOM IC735 coming. The other thing is China have come up trumps, and literally in less than a week I've got a new potentiometer, and it looks like it's the right one. Right. So I should have 12 volts down. So I've got a big one comes across here. I've got a little thin trace there. Jump up to a thicker trace. Comes down to here. So I should have 12 volts on this pin. So let's pop our test speaker back in. I'll say this is just an old CB speaker. It's 8 ohms, but it would just mean it would be a bit quieter. But it should still make a sound. All right. Oh, that made a little whistle then. Did you hear that? Little whistle. I've got to assume this is the ground plane here. It's huge. It's got to be ground there. So we've definitely got 12 volts there to that area. So that's correct. We've got 12 volts there. So up on this IC, which is up. So we've got a bit there. Comes down, goes through there. That's great. So pin 12. One. No. I had a whistling sound coming through the speaker. That doesn't sound good. It's only drawing 30 milliamps, so I can't be wired up the wrong way. I've got 12 volts going in, but it's just making some weird noise. It does sound like there's an issue. So let's see where that play thing is. 1, 2, 3 dot. Ah, it's that pin there. Okay, so I should have 6 volts on this one. And I haven't. I've only got 0.8 on that. So it doesn't look like I've got a voltage to the output IC. Why not? No, is there something on this that's trying to catch me out? I'm thinking. There it goes again, making that weird whistling noise. Rub, rub, rub. Let's see what we got down here. I don't think there's not an AC/DC switch. We've definitely got that linked across there, so we should have our 12 volts either side of that and there, which we have 12 volts there on this 1.2, nothing, nothing, nothing. There it goes again. What is going on with this thing? We definitely have not got our voltage to that IC anyway. We've got 0.8 of a volt, which is strange because we got that down on this capacitor down here as well, which is C. I can't read it. Can't read it. Racing Demon! How you doing, Mike? Watch out for the loose floorboard. Any other part got the 12 volt just in case it's a switch. I read your mind, Tony. Yeah. It does work, but it's not got the 6 volts on it. How you keeping, Mike? Anyway, hope you're alright, mate. I'm pretty sure that says 6 volts. So I'm testing this pin here, look. I'm sure that says 6 volts, but I can check it on the schematic. It says pin 12 of IC302. 10, pin 12. Yeah, so we should have 6 volts there, but we haven't. We've only got 0.8 of a volt. So where is our... That's our output. So it's making lots of weird noises. Where is our power in then? Where's the power rail to this? Is it pin 1 or pin 4? So it looks like pin 1 is our supply. So let's check pin 1. So that should be our 12 volt supply from here, in this area, unless one of these transistors has gone and pulling it down. Yes, there's definitely a 12 volt line there. So pin 1 should be 12 volts. So which one is pin 1? 12, pin 1 is here. So this should be 12 volts on pin 1 there, which is linked to pin 3. So yeah, I can see where that is. So let's check that then for 12 volts. So we've got 12 volts to there. I wonder if that is down low because I've... So when it whistled, did you hear it go up? Do you see it go up in voltage? Have we got something wrong with that chip, I wonder? Or maybe that capacitor down here is not holding its charge. Just have a look, see where that capacitor is in the circuit a minute, because that's exactly the same volts. It's this one. Where are we? In here, I believe. Yes, it looks like C376. Or is it this C378, I wonder? Is it 378? Thousand microfarads. Where's it getting its power from? It's that one up the top there. So we've got resistor that goes through that capacitor there. I bet it's one of these capacitors, you know. I can't remember whether Mark said this was working before. Was it working before, I wonder? I know Mark's probably watching, but he's not in the chat. Was it working? So it sounds like it was working until he pulled it out of the case. So I wonder if anything has killed the radio. I mean, if it was working before, it wouldn't be a capacitor, would it? That's just suddenly failed on us. Although it is possible. Or just looking at the power supply to that has got a capacitor in line with it, you see, which is this one up here. So let me just see if there's any voltage on this one. Let's put that back in again. I wonder maybe if it's not, doesn't like it because it's the wrong impedance. Maybe I don't think it's that sensitive that it needs. It has to have it. Let's just want to check something a minute, because when I fired that up, then let's power it off. So that's strange. With the power switch in the off position, I've got more voltage there. So if I now flick the switch on, oh, hang on. It would help if the blimmin' thing was in the... So wait for it to drain. So look at the power we've got on that one. So 9 volts one side and 0.8 the other. And that's doing its job really in theory then, isn't it? So we've got on this one, we've got 0.8 that side, nothing that side. So it looks like we've got the voltage missing off of that one, which is so this 6 volts should come through. So R362, we should have 6 volts, sorry, we should have 12 volts one side of that and 6 volts. Oh, hang on, no. Where's that getting its voltage? Is that passing? Because that's blocking the DC there, isn't it? So where's our 6 volts coming from? It must be coming from inside the IC then, is it? Let's have a look. Because that's going to be 12 volts to there, then that will drop it a bit down to something else, but that'll only pass AC, not DC. So it's only going to be AC on that. So we should have a voltage on pin 4 as well, dropped by 362. I'm not sure why we haven't got our 6 volts here then. Anyone got any ideas on that? I hope I'm on the schematic. I'm not on the schematic, are you fool? Well, let's try again. So I'm looking at this here at the moment. So we know we've got our 12 volts on pin 1, just here. Come on. Oh. So we've got our 6 volts on pin 1. On pin 12 we haven't got our, sorry, we've got 12 volts on pin 1. We haven't got our 6 volts on pin 12. But because we've got a capacitor here, there's no DC going to flow through there. There's no DC going to come that way or that way. So the only way we can get 6 volts is through this IC. And we haven't got 6 volts. So if we've got our input to it, I'll check pin 4 in a minute, but surely that would mean that that IC stuff, if I've got 12 volts there and no 6 volts here. There it goes again, squealing. You know, we've got some voltage there, but not a lot. Anybody got any ideas on that? Yeah, the meter was in ohms. It's not in ohms anymore, though. Where's the goat? We need the goat here, really, for this. Yeah, so I should blimmin' think so. Yes, yeah, okay, you made your point. So yes, unfortunately I had the meter in ohms before, but it is now back in volts, so definitely I am reading that right. It is, isn't it? It is. That IC is gone, surely. Ivan, how you doing, mate? You've got one as well. Same issue on your IT, a very bad connection from your transformer. C375 shorted. C375. Where am I looking? C375. This one here. Oh, could be, I suppose, taking it to ground. I mean, it could be any of these, couldn't it? Yeah, it could, in theory, be any of these sapping the signal away, couldn't it? I mean, we know we've got our 12 volt in, so this one's probably okay. But it could be C375. That would take the voltage to ground if that one was shorted. 375, as Christian is saying, that could definitely be the same issue. So it'd be worth checking both of those, 374 and 375. Pin 7 is the bypass, but it may be at fault. So let's check 375 and 374 a minute. See if I can find them on the schematic, on the board layout. 374 and 375. So we've got 374. Which is there. Three, 7, 4. That's the 100 microfarads. Yeah, I got that one. 374. That's an ITT branded one. Usually they're pretty good, but I've got a Tycon behind it. I bet that's 375. 379, Tony's going. Tony wants 379. Where's that one to? Where are you looking by? That one there, the 6.8 nanofarad. Could be. So I'm hoping that 374 or 375 is gonna be knackered. So yeah, 375 is up here. So it's these two up in the corner here. I say up in the corner because they're in the corner on the actual radio. So if I go back to here a minute. So those two caps that I'm referring to are these two here. That blue one, which is a Tycon, and the ITT one above. And this is the IC that we were looking at just in there. Get those wires out of the way. Yeah, that's the IC there. I mean, that's a TDA or is it TBA or TDA? It's one of those ones with a heatsink built in. I think it's a TBA 810, possibly 8108. Okay, so negative. See, that other one's got a couple soldering iron marks on it as well, where someone's been in there. Let's take that one out first then. Let's go with the bluey, so the negative is to the left. So I'm just going to put a little dot with which side the negative's on. I'll put a dot on this one to show which side the negative's on. So let's have them out. And there's the goat, by the way, that deservedly came in when I had the meter on ohms. It doesn't do your meter much cop, but this one has got lots of protection on it, so. Let's get the bluey out first, because I reckon that's my favourite, that nasty blue thing. The nasty blue. Just that one there. Just there. big old heat sink, so I might have to just pull that one. Yeah, that one's been leaking. That one has been leaking. You can see that, but I don't know if you can see that on the camera or not. Let me just have a look on the screen. Yeah. Can you see there's some brownie residue on that corner there? So this should be 100 microfarad. Is it 100? Yeah, this should be 100 microfarads. It does look a little bit bulged on the bottom as well, doesn't it? Be like me, really. Bulged on the bottom. I would say that's vented because there's no slits on the toplet. This is a bottom venter. So let's have a guess. Let's get the ESR meter up, and what do you reckon? Have we hit it on the head with the Tycon? 100 microfarads then, 16 volts, place your bets. Will I get another beer going in? Martin, how are you, mate? Have you traced the audio to the chip's input? Not yet, Mike. I'm jumping the gun again, aren't I? Check the input to that output with a signal tracer. Input to the output with a signal tracer. I've gone straight in, am I? Apologies, I didn't catch a chat there, but, you know, what do we think? Is that going to be our culprit, or is it the other one, or... No component detected. Wow. I don't know where my little stand's gone. I think I had it on one of the other meters, didn't I? My little stand. I don't know. I had a bit of a clean up here earlier, but I need a lot more of a clean up, I can tell you. Because this bench is not looking very clean at the moment. I chucked all the paperwork on the floor as well, just for good measure. Right, are we going to do it? Anthony Linoy. Welcome, mate. I'll keep you guessing then, come on. Fat Tony thinks 141. Martin thinks it's gone very, very low. Derek thinks maybe it's a reverse power. Yeah, you could well be right. You could well be right. Let's wait for a few more people. Rolf, how you doing, mate? It's shat its pants. Oh, yours has got a toasted IC as well, Ivan, is it? Were you not able to get another one? It's nice that you got another one, Ivan, because they are cracking little radios. Well, they're cracking big radio, really. There's nothing little about that one. You bet it's stuffed. Derek's reckoning 200. Now, shall I go get the champion in me? I don't know if I need the champion in me. I think I'm gonna go with something like me, really. Something old and peculiar. What do you think? Again, another Mrs. Cruncher purchase. 5.6. To be fair, that's still pretty potent, isn't it? The Legend. 5.6. I'm going with that. An intermediate beer. Darts is on later, so I've got to get Mrs. Cruncher's watching the first half of round 3 at the moment of the German Open. So I'll be joining her for the second half. What Don said, Bob. It would be nice. I mean, it does sound like the chip is working, because it was making a noise when I was like just putting my fingers across it. I wonder if it's available, if it is that IC. It definitely had me thinking I hadn't wired something up properly. Right, let's do it then. Let's push a button. It is measuring 200 microfarads, 198.6, and ESRF 3.2. See under my table? What's under my table? Oh, see me under the table. SIMAP, is it? 199. Hell, you're 0.4 out, SIMAP. You're going to have to try harder next time. So that one is shot. So let me find another 100 to put in there. Yeah, you certainly did, Don. Let me find another 100 to put in there. What do we want? 16 volt. Let's go. Was it 16 volt, that one? At 16. It's fairly close to its rated supply in it, but the other one I got is 50 volts is nearer the size of that one, nearer the pin out. Let me just pop a 50 volt back in there. It won't hurt, I don't think, being it's the Alright, let's just solder that one in. Let's get you up here. See where my legs are poking through. Where are we? There. It's double-sided, this board, so I need to make sure the solder flows through. So I'm just going to pop a bit of flux on that and give it a bit more solder. Just make sure it goes through to the other side. So that particular capacitor was .375 off of pin 7. The other one is 374 off pin 5. I'm going to have to pull that one as well. I could just test it like it is. Actually, let's do that. Let's just test it like it is first. Just see if that has actually cured it. Who thinks it's going to work then? Let's have a vote. Who thinks it's going to work and who thinks it isn't? Let's get a couple of short blocks here just to hold the radio up straight. So who thinks it's going to work? Derek reckons not working. Pepperidge. Well, it was an issue with the transformer pepperidge, but now we've sort of got to the bottom that Maybe there was an issue caused by it being wired up backwards, maybe. Right, power on. No, still just a pip. Let's have a little look, see if the voltage has changed then on that pin. I've done with my multimeter now. So we had 0.8 of a volt. Let's see if we got anything more. Put it in the right way this time. So is that one there? 0.88, no, still not got any output there. Look, 0.88 still. So clearly that hasn't sorted it, just that one. So we're going to have the other one out. If that hasn't cured it, then we can check the other capacitor there, but then it could be time for an IC. So let's get this other one out, which is that one down there. Where are we? That one there. Still got round to unblocking my desoldering gun yet. Okay, so that one's clearly got solder the other side that's holding it still. Better. So what I've done is just put a bit of flux and some fresh solder on it. See if that'll come out now. That was free, just this one. Out he comes, right. Here we go again then, another 100 microfarad. Eyes down looking. Yeah, but I'm not sure on this one whether it looks like it's leaked or not, because I've put flux down through, so it is looking a bit wet, but it's had voltage the wrong way on it, it could well be gone. So another 100. At 10 volt this time. So what do you think? George, how you doing, mate? You've got to move out, George, have you, for it to be done? How's Mrs. Christophe doing? Rob retracted. Is this one going to be shot as well? Are we going to have to be looking at changing all of those in the output stage? Where's me wipes? Where's me big wipes? Where's me big wipes gone? Let's hope I haven't knocked them over because they bleed out all over the floor, they do. Not sure I put those two then. No, I've had my flu jab, George. No ill effects to that, but I've still not 100%, so I haven't had the COVID one yet. Not till my sore throat's gone down a bit. Rob thinks it's the chip. I think you're right, Rob. I mean, while we're waiting for everyone to have a guess on that, I'll have a quick look to see if it's available anywhere. It's probably one of these unobtainium things, is it? It's a TBA 810. Still available on eBay according to this. AliExpress. You just don't know. I wonder if I'm trying to think of the name of the Cricklewood. I wonder if Cricklewood have got one. Cricklewood. They do have some random stuff sometimes. Let's log in. TBA. What did I say? 810. Well, they have. They've got an 810 AP, AS, S or SH. I wonder what the difference is. I wonder what this one's got in it. Nothing. Just TBA 810. It looks like, is it 3 or it could be S, I suppose. It looks like an 8 to me though. It's got DS marked on it, TB8108. Or DS or D5 maybe. TPO 810S. No. Need to go to 810SH. Need to bend tabs, okay. So it looks like we might be able to do it. But we're going to have to bend the flanges to make them fit in the holes, or put some wires up somehow, because it's not quite the same. So if I go to my screen, I'm on Cricklewood here. So this is the one that's in there by the looks of it, the TBA 810S. This is the only one they've got. As you can see, we've got different tabs on it. So they'd need to be bent down. and somehow squeezed through the board to make that connection. I take it that's the ground plane there. But yeah, 83% off. I'm going to have to order one of those, aren't I, possibly? Potentially. Let's see how we get on with this first, anyway. $300 litres of storage boxes with components off the bench. Jesus. Have you heard there's a COVID variant that only affects the fully vaccinated? Never heard of that. Brings back some memories, Tony, does it? Right, let's get back down. Where are we? Where's our suspected dodgy cap gone? Let's do that then. Let's push the button. $121, so that one probably isn't the issue, is it? Yeah, it's gone a little bit high, but it's not mental. It's not gone mad. So who's closest to 121.8 then? 121.8. 114 for Bob. 133 for Derek. Probably Derek, was it? Your first signal tracer amp used that, did it? I wonder if I've got one. I mean, I've got all sorts of random stuff here. Some of it I've inventoried, and some I haven't. I wonder if that's one of the ones that I haven't. So I know I had some stuff from Les. Les gave me some bits and pieces. I wonder if there's one of those chips in there. Cheers, everyone. Old and peculiar, eh? I'll tell you, a pain in the neck this is because it's defaulted to this blimmin' Yahoo thing, isn't it? Search engine. Default is going to be Google. Google. There we go. At least if I'm on Google, I can access photos in my Google Drive. Right. Just got to filter this down a minute. No, I haven't. Not there anyway. But I have seen one of those ICs somewhere. I've got carrier bags full of ICs that I just haven't had time to do anything with. $1977. I don't think we'll get one now. There's a heatsink, is it? I know I've got some containers over here that Les. And I've also got a box full of stuff that I got from a German seller. I wonder if I can, oh, hang on, look. I don't think these are the ones, but I have got some. Anybody know if there's any equivalents? I mean, that's a bit uncanny. That's the first one I've picked out. Now these are TDA 1035s by the looks of it. TDA 1035s, TDA 1170. Just having a look through here, just see if there's any more. It's a treasure trove of stuff that I got from a job lot of parts that I bought in a toolbox. See if there's any more with heat sinks on them. Oh, I got all excited then. I thought I'd come up trumps. Yeah, I'm not sure if any of Les's boxes have got them in. Just having a quick browse a minute, you never know, I might come across it. So we get all these things in for us just in case, isn't it? Lots of just in case stuff. So just in case stuff. No, I can't see anything off the top of me without pulling everything out there. It's highly likely. Oh, it's the same as a TCA 940, Christian, is it? Okay, thank you for that. Used them in TVs, but not for audio. It's very likely that I have got one here somewhere. Like I say, I have got a carrier bag full of ICs. I think what I'll have to do is, if it does turn out to be that, I mean, we'll pop this other cap in a minute and let's see how we get on. Moshi, looks like there's some cold solder joints. Yeah, the soldering doesn't look great, does it? But I can't actually see any definite cold solder joints. I mean, I've just soldered up in the top area up here because I put that other cap in, but I'm going to pop this one back in as well. Then I think what we'll do is we'll test with the signal tracer that we've got, or haven't got, as may be the case, some audio to the actual input of the IC. Now, I'm not sure what pin the signal comes in on. Let's just grab you back over onto the other screen a minute. That's good. So it looks like, is it the signal coming in on pin 8? Yeah, because the supply's coming in there, so it's got to be coming in on pin 8, the signal. So we need to check to see if we've got a signal at pin 8. Just coming off of here. Yeah, that's definitely our audio path, isn't it? Let's just zoom back again. You are on there, aren't you? Yeah. Come back for here. Where's our volume? Looking for the volume pot. That's not the volume pot there, is it? See, I mean, it could be. These are obviously preamp stages here. I mean, it's a hellish loud radio. So I mean, this, I think it says it's capable of 12 watts, doesn't it? That IC. So if you've had power up it the wrong way, it could be all sorts of problems with this. It might not just be this. We could be looking further back through here. It could be a bit of a minefield, really. But definitely we've not got the voltage on pin 12. So we'll check. Pop this one in and check it, and then we'll check to see if we've got any audio on pin 8. Look. That'll tell us if this part of the circuit back here is okay or not. So it could be like a knock-on effect. And let's say we have got this other cap here to check, and this one here could have copped it as well. And these could have copped it. It's never ending. We need to check everything in here, really. Surprising that 220's not gone, really. I mean, it might have done. It might be leaking a bit away. So where we've got standing voltage, once it's running, maybe this one's no good either. I don't know. Clutching at straws, really. But yeah, it looks like pin 8 is the input. Let's get back up on here then. Let's get this soldered in. Ooh, steady. Let's just get this soldered back in. So I say I'm putting a fair bit of solder in there because in fact it is an old-fashioned double-sided board. So we need the solder to flow through both sides. So let's plug that in again. Zoom me out a bit. Big Blockley. Should be close to voltage on pin 4, Meg. Christoph, how you doing, mate? Let's have a look. Where are we? Pin 4. Did we check pin 4? We didn't check pin 4, no. It should, I mean, that goes through. Certainly at pin 1 we've got our 12 volts. Pin 4 could be affected by the other caps, I suppose. But we've got R362, which is 100 ohms. That would drop it a little bit, so we shouldn't have far off 12 volts on pin 4. We can check that anyway. So let's pop the power back on then. Plug my speaker back in. As I say, that one wasn't far out enough to have caused an issue. It's off at the moment. Let's put power on. But you never know. So you heard a little squeak out of that. But still nothing. So let's look at some voltages then. Let's let's just check that pin 4 as Mick's very kindly suggested we do. See if I can find which one is pin 4. So where are we? Where are we? There he goes again. Whee! Six, 5. So pin 4 is in here. So let's turn that on. Pin 4, if my arm's not in the way, which it is. Let's get over this side then. Pin 4 is that one. So that's 9.5 volts on that one. And then we're still at 8 volts on that one. So which one's pin 8? Pin 8 is that one, I think. Yeah, that's pin 8. So let's just get the signal tracer up. See if we can hear anything on pin 8 then. Which I believe is what I said was the input. Making lots of squeaky noises. There's a bloody... Nothing on pin 8. Let's just check, make sure our volume's up. Make sure we're on something we should get some noise on. Nothing. Let's look at where's that going. I wonder if we push the tape button, that will push it down to... I'm just having a think about this. If I push the tape button in, that switches this out altogether and takes our output from here straight into the tape. So we should see it on pin 5 if I push the tape button. So let's pop the tape button in. Now where's pin 5? No, nothing. Mind you, I'm not putting any input in, am I? That's input, not output, isn't it? Of course it is, you fool. Yeah, okay, forget that. That's input, not output. So I need to look back here then, maybe. Shut that up a minute. Where can we go to? So it looks like, is our signal coming out there? 0.5. Where's 0.5 on the board then? 7. Up there. So 0.5 is up here. So that's on light. So it's that track there. So see if we got it on there a minute. Shush. No. We don't appear to have the signal there at 0.5, which is so there's nothing here at 0.5. No signal on the tracer anyway. So 0.4 then, that's before these two transistors. These could have got zapped. 0.4, is that after the IF? So is this the IF module? Potentially. So let's see if we've got anything on 0.4. Let's find 0.4. Six, 5, 9, 3, 1. Anybody see number 4? Or am I not on it? Sorry, I'm not on it. So yeah, what we're looking for now is make sure I'm on that a minute. Yes, I am. So I'm looking for this 0.4. So this, we've just checked for the signal at 0.5 here, which goes into the output stage, and there's nothing there. So I'm just going to go back to point number 4 here, which is, we've got a 0.605, a terminal there, so that must be a link between this circuit and this one, and that's the same as 0.4. So I'm just trying to find 4. So it's 5, 6, that looks like 8. Can't see what that one says. That's 2. Did I say 60? I think that's 4 there, isn't it? Let's have a look. 605? 605, yeah, 0.4 is down there. So where is that? That's on that dotted bit there. So we've got that dotted bit there. We've got that dotted bit there. So pin 4 is... there. Okay, let's try that then. No. So 0.4 is down here. Nothing there either. L, M and K. Nothing there. Okay, well, we're not going anywhere fast, are we? There doesn't seem to be a signal in the radio anywhere. Go back to the schematic. Nothing there at 4, so really that's our IF there, isn't it? So we could go back to maybe that diode's gone. Let's try D601. Where's that to? D601. We've got some voltages down here to check as well by the looks of it. If we could find them on the print. I'll just try to see where D601 is, just to see if I could see if there was a signal there. It's got to be in this area somewhere. These are all resistors. So it joins onto L601, 602, 603. 602. Am I looking in the wrong place? Oh, 601, 602, well, that's 301, 302. What do you think? Let's have a look at the chat, see what you lot are shouting at me. I'm sure you're shouting at me. Harvey's in. How you doing, mate? Use a small amplifier with a probe. That's what I've been doing, Harvey, but I can't find a signal. She's dead. She's dead, Harvey. Just making a weird squealing noise. Squealing like a pig. Invaded by a friend again? Harvey, you got so many friends. This is a problem. No sound? Oh, no sound on the radio now. It is taking 30 milliamps. We've done that. There's nothing there. Trimming resistors open. Anything at the volume control? Not tried that yet. Steve, how you doing, Steve? Volume control. Try feeding the signal to the audio stage from a SIGGEN. Test point 4 seems to be the AM audio. Have I measured the IF transistors? Power supply not getting to the PCB. All the ICs are knackered. Oh, it's not looking good. Mosher, all voltage present at the power supply. Anything on the IF strip makes you think? It could well have been Steve, yeah. Steve Hayward inside the AM can. Go left. Try for audio on the FM. Try a signal generator. Rob. Oh dear, dear, oh dear. The problem we've got is we haven't got the voltage on the amplifier here. So pin 12, the output, we should have 6 volts on that, but we haven't got that. We've got 0.8 of a volts here. So no matter what we do, I think this is gone, but I also think maybe we've got problems further back. We think this is the AM stage here, where I was in AM and I had nothing there on AM. So does FM feed into it somewhere? Is that the FM here? Where does that come off and get fed in? It gets fed in there, then back out there. So that's 0.2. That would be the FM, I think. So maybe 0.2 is the FM. Let's see if we can find where number 2 is. 9 UKW. 3. What point did I say? 2. Was that 2 there? FM? Looks like it is, isn't it? I take it I am on the schematic again. Yeah, so I think this looks like point number 2 here, down in this bottom corner on this lug. Okay, so we can try for that. There's a little squeaklet when I fire it up. Try for FM. Let's put it on FM. This is ground. This is all ground. There's no FM aerial fitted though. Let's see if I can stick an aerial of sorts on it. I can get onto the back of it. Try that again. No, there's nothing on the FM side either. Yes, not looking good, is it? We could have some serious problems here. Let's say if it's had voltage up at the wrong way, it could well be that all the ICs are toast. as someone's just said. So I believe this is FM, this is AM. We've got nothing coming out of either of those. Oh dear. So we can check for the voltages there. On pin 8 we should have 4.9 volts, so we can check that. Because if that voltage isn't present, then that could mean that that one's shot. So let's have a look. That's definitely ground there. I've actually got 0 there on pin 4. And the other test point, we've got 0 on that as well. So on point 4 there we've got 0. Now should that have voltage on it? No, not necessarily. So we certainly haven't got 4.9 volts on point number 2. Not looking good, is it? And he thinks we've got more than just a converter to battery on this one. I think maybe Mark has inadvertently connected it up backwards. Catch you soon, Don. Drop kicking it. It might help. Blowtorch would definitely help. Go left. Trifle, so there's no audio. You write it off, yeah. It's got 0.3, 30 milliamps, Joe. Any chance of checking the voltage on the collector of T308? Let's have a look then. T308. T308. Okay, so that's a transistor, T308, where is it then? T307, what, T307? T305, T308. Okay. I think that's the one I've checked already. Let me just look at the pattern layout. Yeah, I've got the 12 volt to that one, to the collector. I haven't checked the other pin. I haven't checked the 11.5, so we're looking at no, not me, that one. So we're referring to down here, T308. I'm saying this is the supply to the AM and the FM. It comes up to here. So we should have that at pin 5, shouldn't we? Oh no, I'm looking at it. So I've definitely got 12 volts there. I haven't checked for 11.5 on the other one, and I'm not sure what I'm likely to have on this one. Am I likely to have 12 volts on that one? When it's switching? Because if you go back to earlier on, we did check this one down here. .308. Now I did check, and I was getting 12 volts here on the... Is that the emitter? Yeah, the base is the one where I should have 11.5 then. Let's double check that again. Yeah, so we can check that a minute for you. That is down here on this section. So that is across there, up a bit, down a bit, left a bit. That's down here somewhere. Down in there. Let's give that a check. Unfortunately, I'll have to try and work it out from this crazy old diagram here. T308, so that's a base is there, that's the emitter there. Okay, so that's so he gives a little squeak, doesn't he? He gives a little squeak. See if I can get that in so you can see it. Oh, nearly. Let's zoom out a little bit. Right. So I'm pretty sure that that was the 12 volts, which we've got. So the 11.5 should be there. Oh, we haven't got it. So that's our 12. That's the base there, I believe. And that should have 11, but it's not. So what's the other one got? That's got absolutely zilch on it. T308. So it's got the 12 volt on that pin, which is the emitter. It's got nothing on the base and nothing on the collector. Let's go back to the schematic. So we look at this one here, T308. So we've definitely got the 12 volts on the emitter, but we haven't got our 11.5 volts here. So I wonder if this one's knackered then, perhaps. Let's try the base of T309 for 11.5 volts. T309 base is that one there, so that's going to be hang on, they're linked anyway, aren't they? Yeah, they're linked anyway. So we definitely haven't got the on the base there. Well, they're linked via a cap. So if we've not got it there, then we haven't got it here either. So where's it dragging it from? I see 301. God, this is never ending, isn't it? So have we got 11 volts anywhere near R337 then? Where's R337? Can't quite see. I think it's that join on to pin 8. No, pin 5. R337 is this one here. Okay, so I can see that one. Okay, so we've got voltage there. So we've got voltage there on one side of R337. So the other side, we've got voltage there on the other side of R337. Okay. It's unfortunate I can't really make out the I can't really make this out very well. So this is R337 here coming off of pin 5. So you've got our 12 volts there. That's where that's measuring there. So that's saying, hang on, maybe I'm measuring in the wrong place then. So we've got 12 volts there, but that's not the collector, is it? I mean, we should have 11.5 volts, so it's a little bit high. It's 12 volts. Ooh. Okay, I'm confused now. So the base of BC2, I'm just trying to work it out from this terrible scan here. Can't quite, I mean, it looks like the collector, sorry, the base of this one is on this track. We should have 11.5 volts, but when you look at the schematic, I could check R22. That's going to be in that cluster of stuff as well, isn't it? Where's R22? R22? Oh, R338 even. R338 is this one here, so that's where I should have my 11.5. R338. I haven't got that. Where does it come from though? Is it between there and there, I wonder? So where does R338 go to? So we haven't got our 11.5 there, but we should probably have our 12 volt there on that bit there. So we haven't got our 11.5 there, but we've got 12 volt on this pad here. So that 11.5 is feeding this one and this one, but we don't have it. I mean, this is ground here. So where's this 11.5 volts coming from? Is it coming from over here? Or is one of these open or shorted? And it's confusing. It's confusing. Let's just go to the bottom because I'm miles behind. So George is saying T309, T309, T309. Hi Sandra, you're back. And Ben. Check the base of T309, T309. Everyone's thinking T309. So let's pull T309, shall we, and have a look. If I can find out where the hell it is on the grand scheme of things here. T309 is down in this cluster of mess down here. I think it's that one. Yeah, it's that one there, T309. So I'm going to pull it. I'm going to pull it out. I'm going to pull it out. R340 might be open. Yeah, you could be right. Pull T308 as well. Do we reckon this is where the issue is? Do we reckon this is where it is? R340, well, we can measure R340, look, can't we? We should be able to measure that in circuit. It's got a capacitor across it, but let's have a look. R340. So let's see if I can find where the hell that is. R340 is... So curvy bit with that dot there, and then go across. R340. Okay, so R340 is there. R340 is in here. There might be other stuff in here as well, but that is reading 9.75K. And it should be 10K. So that is right. That one's okay. It should be 10K, so it's not far off. It's in circuit with a cap across it, so... So let's pull 309 first and test that. Get off. I'll say this is this horrible double-sided board, so I doubt whether that's freed it up. No, not a chance. Not even slightly freed up. Let's put some fresh solder on and try it again. Tell you what, he ain't coming at all, that one. He does not want to play ball. Got him. He's out. Right. See if we can find the component tester next. That's the next quest, to find the component tester. HFE bingo. Oh, 104A is much more readable, is it? Sorry, Christoph, I can't see all the messages all the time, unfortunately. I do keep missing messages, so you just got to keep reminding me till I see it, mate. But thanks for that. I think it's Christoph. Oh, that's another pair of my pliers there. I wonder where they go. Right, let's see if I can find my component tester. Should be here, but right. Let's have a look. Oh. No, is this because we're not connected properly though? I've got a bit of a bent lead here, so maybe that might be causing some issues. No, they're definitely on. Let's try that again. Okay, that's better. Right, yeah, that one's okay. 221. Let's get the glare off of it and you'll be able to see. Oh. Just didn't have the leads clipped on very well. Just double check that, because sometimes they can they can fail and pass and fail and pass. That one does seem to be okay. Pop that one back in. And let's pull the other one out. Gonna have to solder them and desolder them. Try again. HFE bingo. Ben put that in, did he? Can you check the voltages on T305? Is that the one that we've done? Or have I gone back in time? Is that the one I've just done? Is that 308? I can't remember now. Let's get this one out first and then we'll take requests for testing voltages after we've tested this transistor. My solder sucker doesn't seem to be up to much suck today. Seems a bit gummed up. Probably because of the flux, I expect. Let's give it a bit of a deoxin. Not a deoxin, a deoxit. What? Where's the goat? Goat's gone on holiday again. There he is over there. Isopropylene even. I've got to put a test lead in my beer now. Let's try that again. Let's get my eyes on so I can see what the hell I'm doing here. I can't kind of see what I'm doing. It sucks. It's all going wrong. Just when you thought it was safe to come back into the workshop. Just that one now, holding on. Surely it must come out now. Surely it must come out now. Come out, you swine. It's actually loose. Why isn't it coming out? It's right in tight to this case here. I've got most of the screws out of it. I suppose if I loosen this one over here, it might make my life a little bit easier. Yay! God, I'll tell you what, that one fought, didn't it? It's these blimmin' old double-sided board. Early double-sided boardies. You purchased 10,000 Russian transistors? What? Are you some sort of wholesaler, Danish? Are you offering them out to the community at a reasonable cost? Oh, I see what this one reads. Oh, oh! Now there's interesting. According to that, red and green are shorted. Interesting. Let's have a look what red and green is. Well, let's just check that again. Just connecting these up a different way now. Same as it is in circuit a minute. Red and blue are shorted, so the base and emitter are shorted on that one. What is it? A BC, I can't read that, 252B is it? (252B), a BC 252B. Could this be it? Have we cracked it? Certainly that is an issue. Was it 252B, did I say? I haven't blimmin' got one, have I? BC 252B. Right, now, I did see my Towers book here somewhere the other day. I put it in a very safe place. Towers. You've got to have one of these. So let's have a look. BC. Let's have a look, see what it says suggesting. BC 252B, BC 307 or 2N6015. So 307 or 2N6015. I've got a 307. I have. I've shown it to everyone as well, George. It's not good, is it, really? Ah, damn, I haven't got 307 either. Have I got a 2N6015 though? Two N. No, we haven't got that either. Hell. Right, I'm going to loo a minute while you lot sort all that out. And if you're wondering what George is on about, look at the I wonder if they actually knew that when they did it. Yeah, just look at the first letter of each word. Right, I'm going to go to that loo a minute while you sort me out a transistor. I have got a little box of transistor to have a look through, mind you, so you never know. Right, on my way back. We're not doing well with my spares here, are we, really, at the moment? But then I tend to have a lot of the spares for the English or British radios, but I don't seem to have a lot for the German stuff. Every time I need stuff for these German radios, I tend to have to buy it in. Steve's saying a BC 557, 558. Yeah, I think you're right, Bob. Anything pretty much would do. BC 557, 558. I'm about to have that, Steve, surely. BC. Oh, BC 557. And I've got BC 558. I've got plenty of BC 557s though. Do you think that'll do it, Steve? I'll go for it. Yeah, let's go for BC 557 then. So if we look at my little list here, look. This is my little list of transistors. So it looks like my BC557s are in box 10. Yes. So that might restore the signal potentially, but it might not necessarily restore the output. So let's try it and see. Thanks for that, Steve. Five to be or not to be. Very good, Ben. I see where you're going there. Very clever. Oh, hello. I was going to say my tits fell off the table then, but it wasn't. It was my box of SMD capacitors. Right. Now, is it the same pinout? That's the thing. Is it the same pinout? I'm gonna have to get the tits back out again, aren't I? The Towers International Transistor Selector. We just call it the Towers, shall we, for now? Should we just call it the Towers? That's George's influence again, see? Dragging me down to his level. And beyond. BC 252B, lead info L20, and what was this one? BC 557, BC 557. L15. So L15 and L20. It's a different lead out. So that one is so that's base emitter collector. 15, that's emitter base collector. So the emitter and collector are the wrong way around, so I've just got to spin the whole thing. So emitter base collector. Just got to fit it in backwards then. Like that. Is that right? No, it's the bloody same. It's the same. I was right. I'm cracking up here. I am cracking up. It is the same. You're probably all shouting it's the same to me on the screen, but I can't see it because I'm just got my head in the book here now. Yeah, it's the same, just a slightly different package I saw. I don't know what's going on there. Just going to double check that. Yeah, it's the same. Yep, it is the same. I'm doubting myself again, see? Let's get the eyes back on. Getting late. It's not going to go in there because there's a massive blob of solder on it. I'm going to put some flux on this because the legs are dirty. Dirty legs. Let's get it a bit closer. It says chucking stuff all over the floor again. Hopefully it wasn't the soldering iron. No, we're good. Right, let's see if this has made any difference. So definitely a shorted transistor there. Trying to put the speaker into the power supply. Right, here goes then. Oh. We're drawing more current now. So we've got a short now by the looks of it, because we're drawing much more current and it's going out on the current limit. What's going on now? Unless I've actually put that one in wrong, but I don't think I have. I don't think I have. Okay. Yeah, it's dropping it's going out on current limit on 100 milliamps. Dropping the voltage down to 8 volts. Let's try the current limit down lower. Yeah, 150 milliamps without the current limit. No, that's not safe to run it like that. So we have a short somewhere, so that has got us up and running as far as they're concerned. So what we've got a tantalum in there, I wonder. Can we have a dodgy tantalum maybe? We have a short tant. Let's put that well out of the way over there somewhere. What? Can't be. Measuring 2,940 microfarads. Am I going across the right thing? I'm just going to pop that tantalum out a minute. So that's positive, that's negative. Ten microfarads, 35 volts. Let's have a look. Yellow fracco, yeah, I know. It could be one of the IC shorted though, couldn't it? That's the other thing. We'll start having to disconnect rails and all sorts here in a minute. This could be a part two. Part two coming up, I'm sure. I don't know what, I haven't got a clue what the time is yet. It's not that one, 9 microfarads. It ain't that one. There was a blob of solder on that track. I wonder. I wonder if that blob of solder was causing a problem or whether that was just out of literally just desoldering that there and then. Let's double check that again. No, definitely shorted. So I believe in the last one it was this thing here that was causing the problem, but I think it's three. Is this a 3-pinner or is it a 2-pinner? Let's pop that one out and have a look. Let's pop that one out and have a look. Right, so this one's 2200 microfarads, so it might have been measuring this one in series with the other one, so this one might not be an issue. So what do we think, 2200 microfarads? 2000. Do we think this one's knackered or not? Do we think the fracco's fracked? Do you think the fracco's a load of fracking rubbish? Or is he good, do you think? 2,200. Just out of interest, let me just pop that power supply back in and that on, see if we've still got a short with that cap taken out. Yeah, we've still got a short with that cap taken out, so it's not that one. But let's measure it anyway. Are we all let it go? Two three nine six. So he's not shot as we thought it might have been. 25 volts. Let's just chuck another one in while we've got it out. There's no point putting an old cap back in, really. Only 2200, so. .35 volts. Let's stick another one back in. But it's not going to, because it don't like it, does it? It doesn't like it. I've got to resolder it and desolder it. Could be any of these caps here shorted. It could be an IC shorted. Oop. Come on. Whee. Right, let's just stick that in. sure I've got that the right way around, because that will go bang. Yes, I have. Yep, still shorted. So it could be any of these lot, couldn't it? Just let me have a visual inside a minute, just see if there's any bulging or any cap that looks like it's lifted anywhere. So those two I've done. One of those was bad. We've got a load of other tantalums in here. You know, I mean, that transistor was shorted. Maybe there's another one shorted, you know? Maybe there's a little bit of wire dangling in there somewhere that's shorting it out. Yeah, it's brimming full of tantalums in here. That's loads of them. It's 1, 2, 3, 4, 5, 6. God, there's loads of them in here. Tantalum City 7, another one there. That cap is the wrong way round, is it, George? Cap is definitely the right way around, George. It might not be fitted the straightest in the board, but it is definitely the right way around. The joys. Got 7 minutes, people. So what are we going to look at? We're going to do TBA331 is a transistor array, so maybe the transistors can be tested in it. Might be possible to use discrete ones instead. Can you check out the shorts to the ground pins of the IC301? IC301. Let's have a look then. IC301 is the one down the bottom here. So pins 7 and 13 are ground. So where's IC301 is the next question. IC301 is down here. So what did I say? Pins 7 and 13. 7 and 13. So 1, 2, 3, 4. So 14. So let's have a look then. Let's have a look. See. Just stand it up a little bit so you can have a look. And find the other block. Where is it? Where are you, I see? It's over here. It's over here, Graham. No, that's me. Down there. No, you can't see it. You cannot see it. Down in there, look. Just there. Can I prop it up on that? My multimeter's just about to die anyway, so I can prop it on the multimeter. You can just about see it. It looks like I'm going to have to use one of the older multimeters. Let's put it on. Where are we? Where are we? We've got diode mode, so we'll have to use that as the buzzer. Will that work as a buzzer on this one? Or is this completely knackered anyway, this meter? Yeah, that meter's knackered for some reason. I don't know if the battery's gone alright or it's just kaput. Try another one. Battery's just about to go on my meter. Let's try this one. So pin 7 is that one. Let's just check that to ground. Okay. Okay, so pin 1 is shorted to ground. Pin 1 is shorted to ground. Why is pin 1 shorted to ground? Pin 1 definitely should not be shorted to ground. Pin 1 is the supply, I think. Oh, assuming that is definitely pin 1. It's got 1 marked on it, so you'd think it would be, wouldn't you? Let me just have a look at the schematic. £3.20. Is that what you're charging me, George? Let me just get the schematic back up again a minute. Boom, 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 boom. Right, back on the schematic then. So this one here was shorted. Base to emitter, that was shorted. And pin 1 here is shorted to pin 7, I believe. I'm just going to have a quick look on the layout. Oh, hang on. What? That's backwards. According to that picture, this IC's in backwards because the cutout on the one in the board is over here. So pin 1 and 7 are on the same level, but they are definitely shorted, even if it is the wrong way round on the diagram. So if I go across pin 1 to pin 7, we've got a dead short there. Yeah. So that says pin 7, but in my... I'm not cracking up, am I? Let me just get picture in picture off. Yeah, that's oh, hang on, is that showing we're going the other way round, so this is a mirror image, is it? Yeah, okay, ignore that then. No, so pins 1 and 7 are definitely shorted. So pins 1 and 7 are definitely shorted. So I wonder if that's just taken out that transistor again. I don't know. Any ideas, anyone? So that's a TBA 331. I don't think I've got those either, have I? No. No, I've got none of those. Yeah, there's nothing connected to pin 7 at all. Or pin 13. So should have pin 13 should be shorted to pin 1 as well then, should it? In theory? Seven, 8, 9, 10, 11, 12. Yeah, it is. Yeah. That's a different IC though. That's not, that isn't a TBA 331. Not in here it isn't. In here it is a CA3046, RCA CA3046. Just to confuse things even more. Okay. What is going on here, people? What is happening? What else connects to that circuit trace? I'm not in diode mode, Rob. I'm in resistance mode. Are you going to check it out the board? Yeah, I see what you're saying, Rob, yeah. But, no, not today. C330, Bob is saying. Let's have a look at C330. C330. trying to find C330, Bob. C366 is connected to it, to pin 1, but also connects to pin 4. Yeah, C330 is connected to it. That could ground that pin, you are right. 22 microfarads, C330. So we're here. This C30, look, test point 8, connected via this, it's not actually, it's directly connected to it. So if that was grounded, that would ground that pin, wouldn't it? C330. Let's have a look, see where that is. Where's C330? .330 there. So that is so I see one there. So C330 is just up to the left. What's that one there? It's another tantalum 22. There we go. Let's quickly pop that one out and see then. Where are we? So it's over here. So the positive is that one. That's the positive. That's the positive, right. Let's see if we've got a shorted tantalum then. Oh! Try again. I wonder if we have our issue right there. Can I stick an electrolytic back in place of a tantalum? I think I can, can't I? Just for testing. Won't be quite as stable, but shouldn't be an issue. Well, I've got decent voltage on it. 22, 16 volts. How many volts is that one? 16 volts. Just stick maybe a slightly beefier one in. 16 volts will do. Let's stick a normal one back in there. I'm going to have to... This is where I need my electronic solder sucker, really. Save a lot of this messing about. Right, and I've lost my solder sucker now. What have I done with that? Did I knock that on the floor? Is that what fell down? Sucker of much solder. It's not the greatest board to work on, this, is it, really? I mean, we're just firefighting, I think. We seem to be finding lots of things gone wrong, not just one, so... Tell you what, these holes just will not clear. Will not clear. Just going in with some braid now to try and just clear the holes of solder, because it's, as I say, it's a really old through hole board. I don't think it's through hole, actually. I think it's just double-sided nastiness. Yeah, I don't think these are through hole. I think the component makes the connection, if you know what I mean. Right, let me just make sure I've got this the right way round, the right way round. What is that way? I've got to clear the hole. It's no good. I can't poke it through even, because it's just too. This will not clear. So I got one hole cleared. Got it. Got it in the end. Right, now what do I do with my capacitor? So it's positive to there, negative to there. Right, final try then. Final try. Have we cracked it this time? Or do we need to hunt further? Further. Well, the short's gone, but we still have nothing, no output. We're drawing 40 milliamps now. Let's just see if we've got anything on the amplifier now. I think we have. Yes. I think we're getting there. Let's have a tune to something. Where's the tuner thingy? UK FM. Where's bloody FM on this thing? Ah, there we are. So we should have classic FM there.
Like people who are not boxers. He could fight the ATS, I'm sure.
Right, okay. We have FM. Let's just try the medium wave module, see if we've got a static there. Yes, we have. Okay, so we've got that, but we've got, let's pop it back to FM. So we definitely know we're on.
All driving home from.
Seems to have moved now. Why is that? Still think we've got a knackered audio output chip, but that's get a decent grind. Yeah, so I have got it up here. We've made progress, but we've still got a ways to go yet. So I'm gonna call that a day. But I think we're getting there. So we got a shorted tantalum, we had a knackered capacitor, we had a blown transistor. Shorted transistor, we've had lots of things. Some success. More to come. Part 2. There's definitely going to have to be a part 2. So there you go. Call it a radio. What's that, Harvey? So there we are. That was interesting, really, wasn't it? Trying to get to grips with that. And thanks very much for all your help, because it would have took me a lot longer than that to get to that conclusion. I would have got there, but it would have took me a lot longer. So thank you for that. So yeah, that was a bit different, that one, wasn't it? a bit of combined fault finding again. We like those though. I think that's the ones that go down the better, isn't it? When you've got something that really needs drilling into, a bit of schematic work. So there you go. So thanks everyone for all your support today and for the super chats and tips. Very much appreciated. And this is to be continued next week. I don't really have a lot of time in the week, so thanks, Christian. It was interesting, yeah. Cheers. However, how you doing, mate? We're just going. A lot more fun than a dodgy headphone jack. Yeah, you're dead right. Cheers, Steve. Thanks for your help as well, mate. Yeah, I think I'll pop a new output chip in it anyway. I reckon that's what the problem is. I need to get to grips with that properly. And just make sure there's nothing around that IC shorted as well. Thanks a lot, eh, Russie? Cheers, mate. Yeah, thanks to you all. It's another good get-together, isn't it? So thanks for that. And if you're not a subscriber, I'm trying to get to, I'm trying to think how many I've got now. Have I got 6,700 and something? Or I can't remember now. But I'm trying to get to, I'm trying to get to 7,000 for Christmas, I think. It's 6,000 for Christmas. Sorry, I haven't got that many. I don't know how to get my dashboard up here now. YouTube Studio. Is that it? I forget. Yeah, okay. So I'm 5,766 subscribers. So if you're not a subscriber, hit that button and see if we can get me up to 6,000 in time for Christmas. Look, it's perfectly doable. It's doable, definitely. So cheers all, and I shall catch you next week. Have a good one, and you know, don't do anything I wouldn't do and all the rest of it. Bye for now. Oh, and the new credits are on there with the channel members as well. So we've got Patreons and channel members. If you're not a Patreon or channel member, then you're not going to be on the credits. But if you're not and you fancy it, then push the button for that as well. Bye for now.